What up, guys? It's Obi. It's Friday. Let's see if we can do a little bit of learning today. So we finished up talking about U-joints yesterday. Today we're going to start talking about CV shafts and joints. So this is a pretty good example. This is a front-wheel drive car, and we can see that we have two half shafts, one on the left, one on the right, and they are different lengths. Remember that. So the first thing I want to do is I want to start talking about some characteristics that are kind of similar to all CV joints. So the big thing about a CV joint is that they are going to allow continuous rotation with no change in output speed. So another big benefit of CV joints is that they are going to allow greater working angles than a U-joint. And they do not require proper driveline angles between each half of the joint. So, I want to hit on one thing here and just let you guys know that there are going to be a couple different styles of CV joints. The first one is a Rezepa joint. It's actually pronounced Shepa, just so you know. But however you want to say it, the Rezepa or the Shepa joint is the first joint we have, and then we have what's known as a tripod joint, and then a cross groove plunge joint. Now I do want to stress to you guys that there are actually a couple different extra styles of joints, but these are probably the main ones that we're going to be able to classify them into. So the first one that I want to talk about is a Rezepa joint. This is a Shepa joint. This is a Shepa joint. So we can see it has 6 ball bearings, and I'm pointing at it but not using my pointer. So it has 6 ball bearings here all the way around this, and these are actually going to fit between an inner race and an outer race that you can't see through. Okay, so these joints are going to be able to pivot, and they just act like a big ball bearing is all that's happening. A ball bearing that's transmitting torque. So I want to show you how this joint works. So this is actually kind of neat. It's a translucent view, so you can see through the outer housing. So the shaft right here is connected to this inner race, and the balls are actually located in between the inner race and the outer race. And I don't know if you can see the little curved area, but the ball itself is actually riding in that race. So the nice thing about it is this joint is pretty much a full extension. I don't know what kind of angle that is, probably 30 degrees. And it is actually able to run at that angle without any detriment. Now, I mean, it is going to probably put a little bit more load sideways on this, but in all reality, it's not changing speed. It's going to be a constant output. Whatever the speed is here, it's going to be the same there. So if you guys have any sockets and you've ever used a U-joint swivel, and you know that you don't want to use those on an impact, because with an impact they get to be really dangerous. However, a CV swivel is going to be something really similar to this, maybe not quite so complex, but those are great for use on an impact. They don't really give you any fits. They're not dangerous to use. Okay, so on Shepa joint or Rezepa, one thing that we need to know is it is a fixed joint, and it is probably the most common type of fixed joint currently used. Okay, so it's going to use 6 ball bearings located in a curved race, and it allows for extreme angles with no change in output shaft velocity. It's usually going to be located on the wheel side of the axle shaft. So I'm going to go back to this, and I want to show you that we have the outer CV joint right here, and that outer CV joint is fixed. And what they mean by that is it means that nothing is allowed to move here. So the distance between this shaft and this shaft is fixed. It cannot flex in and out. Okay, and typically we'll find the fixed joint out by the axle or out by the wheel and the hub, because there's not a whole lot of extra clearance for anything to move, because your spring and your strut assembly and your A-arm and everything is kind of right there, so it's hard to have any extra room. Okay, so the next one that I want to talk about, and this is kind of the two joints that you're going to see in a half shaft, is what is called a tripod joint. So it looks a little bit like this. If we can tell, there's a couple key differences. For one, it only has 3 bearings, and 2, I don't know if you can tell, but when you look at this GIF, you'll notice that the housing for where this bearing is can go from here all the way out to here. Okay, now that actually is a plunge joint, which means as the suspension moves and our distance between the transmission and the wheel changes, our CV shaft is able to move in and out a little bit. Okay, this also has to be able to move because when we turn the wheel, it's going to change the distance from the CV shaft to the transmission. All right, so really this is just another style of a CV shaft, and it's one that is going to allow us to send or to transmit power, but still allow this half shaft to flex in and out. Now, a couple things that I want you guys to know about a tripod plunge joint is that it is going to use 3 rulers to transmit power, and the entire ruler assembly is allowed to slide in and out of the housing. But caution must be used not to separate the ball joint, not to separate the joint when pulling, or damage can result. So what do I mean by that? So if we think about our wheel, let's go back to our other picture here. So if we look at our wheel, and let's say we're going to remove the half shaft for some reason, for service or whatever, when we go to take it out, we have to physically disconnect it from the transmission right here. Usually that's done with a pry bar because there's a snap ring, and we can pop that out. But when we're doing this and we try to take it out of the wheel and we grab right here and we yank, well, there's nothing actually holding those bearings in because this is a movable joint. So what can happen when we pull that off, the bearing or the bearings can actually become unseated out of the race, and that's kind of a big problem. And the reason for that is because when we look at this little tripod ball joint right here, or tripod CV joint, goes into the tulip housing, or the outer housing. But a lot of times these little bearings are not actually attached to anything, so they're really just steel rollers with needle bearings on the inside. And if we pull this thing out far enough to where the bearings come out of their housing, the rollers can just fall off and all the bearings fall inside of the boot. And if that happens, you're pretty well stuck, and your only choice is to, at minimum, take the boot off with the with the one-time use clamps, and then put it all back together, reassemble it, and use it. So it's kind of a thing we want to be careful about, because if that happens, you're kind of screwed. Okay. So I do want to let you guys know that it doesn't mean that we have to have just those 3 bearings. We can also have something that's called a double offset bowl type plunge joint. Think of it basically like a tulip joint, a tripod plunge joint, but the difference is that this one actually uses 6 balls instead of those 3 rollers, and it's moving in and out. Same issue, you pull it out too far, the balls are going to fall out and they're going to be laying in the boot, so you still have to be careful, and all the same rules are going to apply. But you could see something that looks like this as opposed to this. Okay, the one thing that we are going to be certain about is that every vehicle, where the heck's my picture? Work with me here. The one thing that we are going to be sure about, though, is that we are going to have a fixed joint and a plunge joint on each CV shaft. We have to have some way to take up that slack. Okay, so that is going to be it for today. We are going to come back to this on Monday, and we will talk about a little bit of the maintenance on CV shafts. But for now, I'm going to say that's it. You guys can do your worksheet and have a great weekend. talk to you later. Bye.